Hello, good evening to all. Welcome to C interview question series. So in this video, we'll discuss C interview question number 2. I take up question number 2 and we'll try to get the solution for this question. So friends, let's get started. Let us first look at the code. What is the output of the following code? So in this, we are given two variables A and B of integer type with values a 13 and b value 5. Then we have another variable k of type float. Then we have an expression a mod equals to b plus 2. Then the next statement printing the values of a and b. Then in the next statement we have another expression k equals to float of a slash b. Then in the next statement printing the value of a k. So this is the given problem and we need to find out answers for a, b and k. Okay, so let us evaluate these expressions and try to find answers for these expressions. So it is better to always solve such kind of problems using memory diagram of these variables. So let us draw the memory diagram for a. Now 4 bytes of memory will be allocated for a and a value 13 will be stored in this. Then another 4 bytes of memory will be allocated for b and a value of 5 will be stored in this. Then we have another floating point variable which also gets 4 bytes of memory. 4 bytes of memory will be allocated for k also. And since k is not initialized, garbage value will present here. So let us find out solution for this statement here. Okay, so in this statement, if you observe a mod equals to b plus 2. So we have two operators in this expression, mod equals to, and we have another plus addition operator. Okay, so when we have such a two operators in an expression, which one is evaluated first, either mod equals to or plus? To understand this, we need to know the precedence of operators. So if you know the precedence of operators, then we can easily evaluate this expression. So let us find the precedence chart. If you don't remember, so open Google and type precedence chart in C in Google. So now you can see various precedence charts displayed here. So open one of the precedence chart. Right. Now if you look at the precedence chart here, the operators are arranged in this chart from high precedence to low precedence. As we move down the chart, the operators with the low precedence are arranged in the bottom of the chart. So what operators we have? We have two operators. One is mod equals to and another one is plus operator, addition operator. So where are these operators which is having high precedence? Let us find out from the chart here. Now if you see the chart, so here we have the addition operator. Then if you move down the chart, at the bottom of the chart we have, see here, mod equals to. Okay, so that means the addition operator has high precedence. So that means this addition operation is carried out first. That means the expression b plus 2 is carried out first. Okay, so the value of b is 5 here. Value of b is 5 here. So a copy of value from b is taken here 5 and 2 is added to this value. Okay, so then on this expression here we get a value of 5 plus 2 7 here. 5 plus 2 7 we get here. So then a mod equals to 7. Then the expression in converted into this form, a mod equals to 7, which is nothing but a equals to a mod 7. So what is the a value here? So a value is 13 here. So it is 13 mod 7. Now if you divide 13 with 7, then the remainder, the modulus operator gives you the remainder. So 7 1 just 7. Then we get the remainder as a 6. Okay. So then this remainder is returned by this modulus operator. So that means here we get a value of a 6, and this 6 we are assigning back to a. We are assigning this value back to a. So that means in a previously 13 was there. Now the value of 13 is overwritten by a value of a 6 here. Now 13 is gone. Now the value 6 will present in this a. Now if we go to the next statement, in the next statement we are printing the values of a and b. So it is better always look at the memory diagram of a and b. What is the current value of a in memory? So we have 6 here. So that means from this expression we get yes, I am writing the output here. So we get a value as 6 and b value as 5. So friends, remember in this expression b value is not changed. B plus 2, that means 2 is not added to b inside the memory. A copy of value from b is taken. A copy of value from b is taken and 2 will be added to that constant value. So 5 plus 2 will become 7 on the right hand side of this expression. So the b value inside the memory remains 5 only. It won't change. So this we should understand, we should remember. Now if we evaluate the next statement, k equals to float of a slash b. Here also we have two operators. One is called as a typecasting operator and another one is called as a division operator. Okay, so which one, typecasting or division, which is having high precedence, we need to understand. So let us go back to our precedence chart. So in the precedence chart, if you see here, in the second row, we have C within the parenthesis type. This is nothing but typecast operator. This is typecast operator. Then in the next row, we have slash operator, division operator. So that means the typecast operator has higher precedence here. So let us evaluate our expression. So that means in this expression, first the typecasting will be performed here. So that means A is of which type? A is of a integer type here. A value is declared as a integer type here. So that means the integer value of A is first converted into float. Okay. So that means here what happens means, what is the value present in A? It is 6. Okay. So that 6 will be converted into float as 6.0. It is converted into float as 6.0. Then slash b. What is the value of b? It is nothing but 5. So then k expression becomes like this, 6.0 by 5. So one, in an expression we have one floating point value and one integer value. Okay, so when such different types of values are present, what the compiler will do is implicitly it converts the lower data type to higher data types. Here integer is considered as lower data type. So that's why this 5 will be converted to floating point type like this 6.0 slash 5.0. This is called as a implicit conversion. And the first one is called as a explicit conversion. This is called as a explicit conversion. And here this is called implicit type conversion. So now we have two operands of same type, floating point type 6.0 slash 5.0. So if you divide 6.0 with 5.0, then we'll get an answer of 1.2 here. Okay, so if you divide 6.0 with 5.0 or 6 with 5, okay, so 5 ones are 5 here. So then decimal point take 0 here, 5 twos are 10. Okay, so that means we get the quotient in floating point number. So this division operator gives the quotient after the division. So we get a value of 1.2 on the right hand side of this expression. Okay, so on the right hand side of this expression here, we are getting a value of 1.2, and this will be assigned to k. This will be assigned to k. So when this 1.2 is stored in k, because k is declared as a floating point type, so by default, a floating point variable stores the value up to 6 decimal places. So then it will be stored inside the memory as a 1.200000. So inside a memory of k, the value will be stored up to 6 decimal places after the decimal point. So it will be stored as 1.200000, 5 zeros. So it stores up to 6 decimal places. Now go to the next statement. In the printf statement, we are printing the value of k. But what is the control string given here? So it is percentage dot 1f. That means this indicates print the floating point value 1 decimal place after the decimal point. Okay, so print the value of k up to 1 decimal places. That means, so here it has stored up to 6 decimal places. So in this format, if you print the output from this expression, it is 1.2. That means you are printing the value up to 1 decimal places. So that means the remaining trailing zeros will be removed and only 1 decimal place it prints, 1.2 it prints. Okay, so friends, this is the final output when we execute this piece of a code. Okay, so return 0, close. So 6, from the first printf statement, a value and b value, it will be printed as 6 space 5. And in the next printf statement, when you print a k value, it prints as a 1.2. Okay, so having given here just percentage f, if it is percentage f within the double quotes, then it would have been printed as 1.20000 up to 6 decimal places it would have printed, but the control string mentions that print only 1 decimal place after the decimal point. So that means it prints only 1.2, only 1 decimal place it prints. So this is the output from this code. So hope you got the way expressions are evaluated by the C compiler. So whenever such kind of questions are given, it is better to remember the precedence of operators. So operator precedence, if you remember, then you can answer such kind of questions easily. So let us verify the solution using a C compiler. So let us open a C compiler. So open a browser, type online C compiler. So open the online C compiler here. So let us copy our code. So this is our code. So let me just copy this code and paste this code inside the browser. So here we have some these double quotes we need to change here. Okay, otherwise it gives error. Right, so everything looks fine, friends. So now run the code, click on this run button. Yeah, at the bottom of the screen you can see the output displayed here, 6, 5 and 1.2. So this is the output from this code. So as I mentioned, having given percentage f, if it would have mentioned percentage f, then let us see the output. Now it prints 1.2000. Okay, but in question it is clearly mentioned that print only one decimal place after this 0.1 f indicates that you are informing the compiler to print one decimal place after the decimal point. Restrict to only one decimal place. Restrict the output only to one decimal place. So that's why then it prints the output as a 1.2 only. So friends, if you think this is useful, please like, share and subscribe to my YouTube channel. Thank you one and all.